All righty. So on the bell work, we have two separate templates that we're going to be using. We have this one here. We have this one here. This is the question that we're actually going to be asking or answering. So first, always want to pay attention to the information that's given to us. They provide you a little nugget of wisdom down here in this paragraph. It says one method of calculating the approximate age in years of a tree of a particular species is to multiply the diameter of the tree in inches by a constant called the growth factor for that species. So what that means is that we could write an equation that age is equal to the growth factor, I'm just going to abbreviate, times the diameter in inches as multiplication, right? And we have the growth factors listed there. It says the table above gives the growth factors for 8 species of tree. So which one do we care about? That's where we go to our question. So it says, according to the information in the table, what is the approximate age of an American elm tree with a diameter of 12 inches? So we have our diameter. We just need the growth factor. So the growth factor is written in the table is 4. So 4 times the diameter of 12, that's going to equal the age. So 4 times 12 is equal to 48. Therefore, we can assume that the age is equal to 48 years. And I believe that corresponds to answer choice D. So just on the SAT and stuff like that, just be aware, read through everything, don't skip through, right? Because you'll miss little pieces of information like that, and you really wasting time if you have to go back and reread it when you could have picked it up the first time. All righty. So 5-minute check. It says find the amplitude of y equals 3 cosine of theta, then graph the function. Okay, so if you remember from last week, our sine, cosine, and tangent functions can be written in a form like this. A times the sine of b theta plus c plus d, where A is the amplitude, B is the period factor, C is the phase shift, and D is the vertical translation. This one, it's a cosine, so that's still going to be A times the cosine of B theta plus C plus D. So in this one, we have y equals 3 cosine of theta. So the amplitude is given from the absolute value of the A variable. So in this case, it's the absolute value of 3, which is just equal to 3. Okay, remember we always want to find the period. Okay, you take 360 degrees, or 2 pi if we're working in radians, and we divide that by the absolute value of B. The value of B in this case is 1, so our period is still just 360 degrees. Okay, from that we want to find our x scales, the locations of our critical points. We take the period we just found, 360, and we divide that by 4. We get 90 degrees. And remember, that's going to be the location of our maximum, minimums, and where we hit the midline. Okay, then you consider the phase shift. That comes from C and B combined. Okay, but in this case, since C is 0, the phase shift is 0. Vertical translation is 0 as well, because we do not have a value of D. Remember, anything in math, if it's redundant, it's omitted. So if it's plus 0 or minus 0, you're not going to see that in the equation, but you can assume it's there. So what our graph looks like, if I draw my axes here, I have an amplitude of 3 with no vertical translation. So that means that my graph is going to go from 3 to -3, with the midline being at the x-axis. Okay, my x scales say that I have critical points every 90 degrees. So I'm going to take that into consideration. 270, 360. Okay, it's the cosine graph. Cosine starts at its maximum. Then it goes to its midline. Then it goes to its minimum. Then it's back to its midline. Then it's back to its maximum as one full period. Follow it in with a smooth curve. That's a terrible graph, but it gets the point across. Okay, you can see in this or on the actual equation that they gave to us is that they've expressed it in radians. Okay, in this chapter, we're going to need to go back and forth between radians and degrees very simply, very easily, because some of them are going to require you to graph it. Just remember 2 pi is equal to 360, pi is equal to 180, 3/2 pi is 270, pi over 2 is 90. And I'll write those up on the board after we get through the 5-minute check. So find the amplitude. So the amplitude was 3. The graph right there, they've taken that for us, so we can conclude this is C. I don't know why they didn't select a bunch of graphs for us to choose from, but that's just the way the world works. I'm not very impressed with these slides right now. So here, we have find the period of y equals sine of 3 theta, then graph the function. Okay, so we're going to use our same information, but this time we're going to do it in radians. Okay, because the x scales that are given to us are in radians. The beautiful thing is everything is still the same. Okay, it does not change if you're dealing with degrees or radians. It's the same process. So we're given y is equal to sine of 3 theta. Bang, like that. So the amplitude, still the same thing, comes from the absolute value of A. The value of A right now, so it's the absolute value of 1, which is just equal to 1. Here we have a period change. Okay, remember, if B is a whole number and it's greater than 1, so it's not a fraction, that means the graph gets compressed horizontally. If it's a fraction, it gets extended horizontally. So our period, like I said, I'm going to do it in radians this time. So it's 2 pi, because 2 pi is equal to 360. I'm just going to divide that by the absolute value of B, which is 3. So that is 2 pi over 3. Cannot be simplified any further than that. That actually is enough information to have us graph or answer a question that's on there, but we're going to walk through the x scales. The same thing. We take the period that we just found, which in this case is 2 pi over 3. We're going to divide that by 4. So 2 pi over 3 divided by 4, in all reality, is 2 pi over 12, or can be simplified to pi over 6. Okay, because 2 goes into 12 6 times. Phase shift coming from C, there is none. C is 0. Vertical translation comes from D, is none as well. Okay, so starting with my graph, I haven't moved it off the x-axis at all, and my amplitude is still 1. So my graph goes from 1 to -1, with the midline being the x-axis. So sine, or label for my x scales, says that every pi over 6, I should have a critical point. So the first one is pi over 6. The second one is 2 pi over 6, or pi over 3. Okay, the third one is 3 pi over 6, or pi halves if you simplify. The fourth one is at 4 pi over 6, or 2 pi over 3 if we were to simplify. Okay, so just be aware when you're looking at that, especially if you're using like Desmos or a graphing calculator. Desmos simplifies them already. Okay, sine function starts on the midline. Bang. Then it goes to its maximum. Then it goes back to its minimum, or back to the midline. Then it goes to its minimum value, So I have to erase my little simplifications. And then it goes back to the midline to start a new period. That's what it looks like. Completes a full period in 2 pi over 3 radians. That was the question that they asked because they asked us to find the period. So this one should go for letter A. Still fluctuates between 1 and -1 because that does not change because our amplitude factor did not change. Okay, write an equation for the tangent function with a period of 40 degrees. Okay, this one's a little different because they've given us the period and we have to find out what our value of B is going to be. Okay, remember tangent, it can be expressed in the same parent form or general equation as cosine and sine, where it is A times the tangent of B theta plus C plus D. So in this case, A is the amplitude, but for tangent, it's really an irrelevant statistic because tangent goes from -infinity to +infinity in terms of the range, so the amplitude is none. B is still the period factor. C is the phase shift factor. D is the vertical translation. Okay, so in this case, they said that we want the period to be 40 degrees, and for tangent, we take 180 over the absolute value of B. Okay, so here, what we got to do is solve for B. Okay, so we multiply by B on both sides to get it out of the denominator. So that's B times 40 degrees is equal to 180 degrees. Okay, then we divide both sides by 40 to find that B is equal to 180 over 40, which simplifies down to 9 over 2. Attach that with theta. So the equation that we're looking for is tangent of 9/2 theta. The marker's wearing down. All right, so this one kind of introduces what we're talking about in a vertical translation aspect. Okay, but you can see it's kind of written in a funky format. Okay, it doesn't necessarily follow the trend of the actual equation. It says a population of insects can be modeled by the equation y equals 12,000 plus 8,000 times the sine of x over 6. What is the greatest number of insects you will find? Okay, so it's population and they're modeling it with a periodic graph. So first thing I want to do is I want to rework this so that it fits this format. Okay, so since it's 12,000 plus, I'm going to move that 12,000 to the end. Okay, so it's really y equals 8,000 sine of x divided by 6 plus 12,000. Okay, now it's in the format. So A, my amplitude is out front. Okay, the amplitude, once again, is the distance from the midline. So we know that we're going to go 8,000 from wherever the midline is. Okay, that's where D comes in. D shifts the midline up or down. Okay, when you're talking about sinusoidal functions. So in this case, this one is not on the x-axis. It's actually 12,000 units up, and we have an $8,000 or 8,000 unit maximum. I don't know why I almost said dollars there. We're talking about insects. But so what that means is that if I were to try to graph this, okay, and I'm not going to, my midline would be 12,000. Okay, and I go 8,000 units above that line and 8,000 units beneath that line. So what's 8,000 units above? Well, 12,000 plus 8,000 is 20,000. Okay, that's where my maximum is going to fall. Okay, my minimum would be 12,000 minus 8,000, which would give me 4,000. So that's where the insect's population fluctuates. A minimum of 4,000, a maximum of 20,000. So when they ask us what is the greatest number of insects I would find, I'm looking for my maximums. Okay, at any given point in time or over the period of this cycle, the greatest amount that I'm going to find is 20,000. Perfect. Okay, here's what we're talking about now. We've translated exponential functions. We have done that. We're going to graph horizontal translations of trigonomic graphs to find phase shifts and graph vertical translations of trigonomic graphs. In other words, we're taking into consideration the phase shift and the vertical translation. So you have phase shift. Okay, phase shift is very similar to a horizontal translation. You're moving the graph left to right. Okay, left or right, excuse me. Okay, the next one is vertical shift. That is moving the graph up or down. Okay, and what you move when you're doing these vertical shifts is you move the midline. Okay, which on the parent graph for both sine and cosine is the, or for all three of them actually, the midline is considered the x-axis. Okay, but if we have a plus d, that moves it up. If we have a minus d, that moves it down. Okay, before we get too far into this, I'm going to give you certain radian to degree conversions, you could say. Okay, but you should already be aware of this, but just to emphasize the fact. Okay, so 30 degrees is equal to pi over 6. 60 degrees is equal to pi over 3. 90 degrees is equal to pi halves. Okay, 120 degrees, that's 1, 2, 3. That is 2 pi over 3. 150 degrees is 5 pi over 6. 180 degrees is just equal to pi. Okay, then you have 210 degrees, which is 7 pi over 6. 240 degrees is 4 pi over 3. 270 degrees is 3 pi over 2. It's continued over here. 300 degrees is, it's a good one. It's 5 pi over 3. When it's simplified, 330 is 11 pi over 5 pi, no. 330. Oh, give me a second, I'm running through them in my head. 360 is equal to 2 pi. So 330 is 11 pi over 3. I believe. 3 halves pi, 300. Okay. I buy that. And 2 pi. Okay, the reason I'm giving you these is because we got to graph them in radians as well. So I don't want you to get really dismayed by the conversions. Okay, I just counted by 30s. But in this case, it's going to be okay. As long as the big one that you remember, the big 2 pi is equal to 360 and 180 is equal to pi. Those are the big ones. 30 times pi over 180. Oh, 11 pi over 6. Dang it. Not 11 pi over 3, 11 pi over 6. Crap. But it's okay. Should be better than that. Should be better than that. All right then. Okay, so what we've done previously is we've adjusted the amplitude and we've adjusted the period of these graphs. Like I said, today we're moving them left to right and up and down. Okay, the book, it gives you a method, but the method that it works really isn't the greatest. Okay, it makes it a little bit more complex. There's an easier way to do it, but we have to adjust our equations each time. So here's the concept of the phase shift as the key concept. Okay, it says the phase shift of the function y equals a sine of b theta minus h. Okay, I abbreviated as c, and y equals a cosine b theta of minus h, and y equals a tangent of b theta minus h is h where b is greater than 0. Okay, so and you can see that when it's a negative, we're shifting h units to the right. And when it's a positive, or when it's when it's a positive, h is going to shift to the left. Okay, so inside, outside. You can see on the examples here, y equals cosine of theta minus 90. The phase shift is 90 degrees to the right, and that's really your starting point. Okay, for the tangent of theta plus 30, the phase shift is 30 degrees to the left. So if you see a minus on the inside, you're shifting to the right. If you see a plus on the inside, you're shifting to the left. Okay, and that just becomes the nature of the format because the book's standard format is to have a negative there. We're going to find a method that really helps, is pretty consistent for all the functions. Okay, it shouldn't change at all. And what it requires us to do is we're actually going to distribute the b value into theta and h in this case, or the way that I express it, BC. Okay, so we're going to have to do that one step, and then we're going to graph it the same way. Okay, and that's because when you're considering a phase shift, you have to take into consideration the period. Okay, the book just says if you find the period and you do this phase shift, you'll get the correct answer, but it's a whole lot harder to wrap your head around, and it's a whole lot more processes to go through to solve. But by distributing B in, it makes it a little bit quicker, and then you have solid rules on how to solve everything. Okay, so the first one. So state the amplitude, period, and phase shift for the function y equals 20 sine of theta plus 20. 2 sine of theta plus 20. Dang it. Okay. So we're still using these general formats. Okay, in this case, I have the graph y equals 2 sine of theta plus 20. Okay, and the first step that I said that we're going to do, first we can see that we're going to graph this one in degrees, but then we're also going to distribute B in. Okay, so remember the value of B and what it means to distribute is we're going to multiply it by theta and we're going to multiply it by C. Okay, in this case, B is 1. Okay, so this is an easy one. And after I distribute that, I want to rewrite my equation. So this is really 2 sine of 1 times theta, which just gives me theta, and 1 times 20, which just gives me 20. So you can see this is me rewriting the equation, okay, because I distributed the 1 in. What this allows me to do to calculate my phase shift is I can set this interior period, or this interior, whatever's in the parentheses, I can set that equal to 0 and find out what my phase shift is. Okay, so after I've distributed and rewritten my equation, okay, then I can go into considering the amplitude and all that good jazz. So 2 sine of theta plus 20, and this is what it would be after I distributed. So the amplitude, okay, still comes from the absolute value of A. So this is the absolute value of 2, which is just equal to 2. Okay, the period. Since we're graphing in degrees, I can take 360 divided by the absolute value of B. The value of B in this case was 1, so I still have 360 degrees. Okay, my x scales. Okay, still going to factor in that. Okay, take the period that I just found of 360, divide it by 4, that equals 90 degrees. So every 90 degrees, I have a critical point. Here, my phase shift, after distributing, you can see I have a value in there. If I set whatever is on the inside equal to 0 and then solve, it's going to let me know where my starting point is. So I'm solving for theta. Okay, so it's theta plus 20 set equal to 0. If I minus 20 on both sides, I get that theta is equal to a minus 20. Vertical translation still comes from D. There is no value of D, so it's 0. So there is no vertical translation. What does this mean to me? My graph goes between 2 and negative 2, coming from the amplitude. Period is still 360. I'm going to have a critical point every 90. I'm shifting it 20 units to the left or 20 degrees to the left, and the vertical translation means that I'm still on the x-axis. Okay, so 2 is my maximum. Negative 2 is my minimum. Got to extend it out just right here. And I found that I began at a negative 20 degrees. Okay, now what I want to do is I want to add my x scales to where my phase shift was. So a negative 20 plus 90 gives me 70 degrees. Okay, that means my first critical point is at 70 degrees. My next critical point is 90 degrees from that. So 90 plus 70 is equal to 160 degrees. That's my next critical point. 160 plus 90 is equal to 250. That is my next critical point. And then 90 plus, or 250 plus 90 is my final critical point, which is 340 degrees. Okay, and here I have an opportunity to double check my work before I get into the process of graphing, right? So my period was 360 degrees, and I know I'm going to complete an entire cycle, okay? But I was shifted 20 degrees to the left. So I have to end at whatever 360 plus my phase shift is. Okay, 360 plus a negative 20 is 340 degrees. Okay, if I had shifted it right 30 degrees, I would take 360 plus 30 and I'd get 390, and that's where my graph should end. Okay, so I've built in little checks here to accomplish this. Okay, but the phase shift comprised with your x scales is how you find the locations of your critical points. But you have to factor in the period as well. This one, our period did not change, so we're just dealing with the phase shift of negative 20. So sine function starts at the midline. Okay, then it goes to its maximum, then it goes back to its midline, then it goes to its minimum, then it goes back to its midline. Just like that. Okay, it started at negative 20. It ends up at 340 because one period is 360 degrees. All I did was shift it left. And that, once again, was because I had a positive on the inside. Okay. However, since h is negative 20, go to the phase shift negative 20 because h is less than 0. Parent function is shifted left. So the dotted line is 2 sine of theta. You can see that it starts on the midline, which is the x-axis, goes to its maximum, minimum, all the way through. R starts at -20, maximum at 70, midline at 160, minimum at 250, completes the period at 340. Okay, pretty simple, very process driven. Okay, but the key is, and the key point that I want to get to is that I distributed B in so that I could take care of the phase shift and the period at the same time. Okay, this one was simple because my value of B was 1. Anything multiplied against 1 is just itself. Okay, so I didn't have to really take the period into consideration here because the B value was 1. So here, we're stating the amplitude, period, and phase shift for the function y equals 3 sine of theta plus 30. Okay, so if we consider all of our information, I won't graph this one to save a little bit of time because it's not asking me to, but I'm going to write all of the information like I was going to graph it. So first step is to distribute B into my equation. Okay, so in all reality, this is written as y equals 3 sine of 1 theta minus or plus 30. Okay, and I want to distribute this one in. 1 times anything is itself. So after I've distributed, I'm working with the same equation as y equals 3 sine of theta plus 30. Okay, so that's just emphasizing the distribute. It's easy with these ones, but as you get farther and farther along, there's going to be a problem where it's very, very hard. And I'll show you one too. Okay, amplitude still comes from A. It's the absolute value of 3, so it's just 3. Period, we're doing it in degrees. Okay, so that's 360 over the absolute value of B is equal to 360 because my value of B is 1. X scales, take 360, the period you just found, divide it by 4, you get equal to 90. The phase shift, now that I've distributed, I can take theta plus 30, what was inside the parentheses, set it equal to 0 and solve for theta. So minus 30 on both sides, I get that theta is equal to a negative 30. That means my graph has been shifted left 30 degrees because I ended with a negative. Vertical translation comes from the value of D. In this case, there is no value of D, so I am good. The question asks, find the amplitude, which is 3, the period, which is 360, and the phase shift, which is negative 30. Okay, so now it's just picking the answer choice that has all that information and then going from there. So in this one, it looks like it should be C. Did that help clear it up at all? Let's see. Yeah, it did. Ha 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 ha. It's no longer blurry. Technology, man. Okay. Vertical shift. Okay. This is the phase shift, or it's not a phase shift because phase shift is moving it horizontally. Vertical shift is moving it up and down. Okay. And what we do when we take the vertical shift is we move the midline. Okay. We move the midline from it. So we still have amplitude as the distance from the maximum to the midline. The vertical shift moves that midline up and down. So it's no longer the x-axis. Okay, it says the vertical shift of the functions y equals a sine of b theta plus k. Okay, and vertical shifts come from the outside. Y equals a cosine of b theta plus k. And y equals a tangent of b theta plus k is k. Okay, so if k is positive, so we're adding it, we're shifting it up. If k is negative or we're subtracting, we're shifting down. Okay, so an example, y equals the sine of theta plus 4. Okay, that's shifted 4 units up. Okay, y equals tangent of theta minus 3. That's shifted down. This gets a little tricky because if you see the way it's written, is because that kind of looks like it could be a phase shift, right? If it is a phase shift, they will put parentheses around it. Okay, theta minus this in parentheses. Okay, if it's a vertical shift, it'll be outside of those parentheses. All right. So state the amplitude, vertical shift, and equation of the midline for y equals 1/2 cosine of theta plus 3. You can see there is no parentheses, so we assume that this is outside. So we're going to handle it the same exact way. Okay, and I'm still going to distribute everything in. So our original equation was y equals 1/2 cosine of 1, I'll even add c, theta plus 0 plus 3. That way you can see the phase shift. Remember, if it's on the inside of the parentheses, you're moving it left and right. If it's on the outside of the parentheses, you're moving it up and down. So I want to distribute this 1 in. Beautiful thing is 1 times anything is just itself. So y is equal to 1/2 cosine of theta, because 1 times 0 is 0, plus 3. That's my new equation. That's the one that I'm working with. Okay, and then I treat it the same exact way. Okay, the amplitude comes from the absolute value A. So our value for A is 1/2, so the amplitude means that it's 1/2. The period, okay, we can do it in, I'm going to do this one in radians. Okay, just so you guys get more familiar with the process. We could do it in degrees, it's the same thing. But in radians, I'm going to take 2 pi divided by the absolute value of B. B is 1, so my period is still 2 pi. Okay, my x scales, I take the period that I just found, which is 2 pi, and I'm going to divide that by 4 and simplify. That means every pi half, I have a critical point. Okay, if you remember, 90 degrees is equal to pi half, so this makes sense. Okay, it's still the same thing, you're just doing it in radians. The phase shift, if I set what's on the inside, which is theta plus 0, set that equal to 0, you're going to find that theta is equal to 0, and the vertical translation is plus 3. Okay, so that means I've gone up. Okay, so the first thing I want to do, draw my graph. Okay, I'm going to put my x-axis down here, and then I'm going to change colors. So with this vertical transformation of 3, like I said, that means that we've adjusted the midline. Okay, the midline has come 3 units up. Then I'd factor in my amplitude. The amplitude is the distance from the maximum and the minimum to the midline. So if my midline is 3, my maximum value has to be 3.5, and my minimum value is 2.5. Okay, my x scale says that every pi halves, I get a critical point. So you can see where my x-axis is. So it's pi halves, then it's pi, then it's 3 pi over 2, and then it's 2 pi. Okay, cosine starts at its maximum, in this case would be 3.5. Then it goes to its midline, then it goes to its minimum value, then it goes back to its midline, then it finishes at its maximum. Okay, so my cosine graph.
Please excuse this interruption. At this time, we will conduct a lockout drill.
Resume the recording. Okay, so you can see that the process of graphing it, the actual process, is the exact same. The only thing that changed was I moved my graph 3 units up. I know cosine starts at its maximum, then goes to the midline, then goes to the minimum, back to the midline, back to its maximum. Okay, if I know that, I know the location of my minimums, and I take into consideration where my x scales are, it's the exact same process over and over again. Okay, but the first thing I want to do is take care of my vertical translation. Then I use my x scales to fill out my x-axis, or vertical translation and phase shift. Take your x scales into consideration. And this graph is just compressed vertically because it has an amplitude factor of 1/2, but it's shifted up 3. So instead of going from 1/2 to a negative 1/2, it goes from 3/2 to 2.5. So the amplitude is 1/2. The period is still 2 pi. The vertical shift is 3, so the midline of the graph is 3. You can see that they've drawn the midline. Okay, the amplitude of the functions is 1/2 and 1/2 above and 1/2 below. So they tell you to draw those little lines, but it's not really necessary. And then you can draw the cosine curve. You can see it started at 0, then at pi halves, it's touching the midline. Then at pi, it's at its minimum. 3 pi halves, it's back to the midline. And then it completes its period by getting back to the maximum. Okay, for your cosine graph. I just need 1 second. So, don't you love getting old? They recommend all of these surgeries and stuff, but it's okay. I'm going to make it. All right, so example 2. We state the period, the amplitude, the period, vertical shift, and the equation of the midline for y equals 3. Okay, y equals 3 sine of theta minus 2. So I'm going to treat it the same exact way. I'm just not going to graph it because the question does not make me graph it. But I go through the same exact process. Okay, I know it's redundant. Hopefully it gets burned into your head. That way we have no issues. If you treat it and trust the process, you will get the correct answer. You'll only have problems if you do not trust the process. So y equals, this marker's going dead. Y equals 3 sine of 1 theta plus 0 minus 2, just filling it out. Then I would distribute 1 in, right? 1 times anything is just itself. So the equation I'm really working with is 3 sine of theta minus 2. Okay, so what did this do for me? It's moved my graph down, but it's expanded it vertically. So the amplitude comes from the absolute value of A. It's the absolute value of 3 in this case, which is equal to 3. The period, okay, it's either 2 pi divided by the absolute value of B or 360 divided by the absolute value of B. Both are acceptable, but in this case, I'm going to do it as radians again because you have less experience with that. So 2 pi divided by the absolute value of 1 is equal to 2 pi. Okay, my x scales. 2 pi divided by 4 is equal to pi halves, and that's because I have 4 critical points for each period. The phase shift, set what's on the inside of the parentheses after I've distributed, set it equal to 0. Theta plus 0 is equal to 0. That says that there's no phase shift. The vertical transformation is -2. Okay, so what this did is I've moved my midline down 2 units from the x-axis. So my midline should be a -2. Okay, my period is still 2 pi and my amplitude. So amplitude is the distance from the maximum and the minimum to the midline. So this graph goes from 1 to -5 because the amplitude is 3. It's the distance from a -2. Okay, so if I'm looking at my answer choices, I find the one that has all that information. Amplitude is 3, so I can eliminate C and D. Okay, the period is still 2 pi. So my vertical shift on A is -2. That corresponds. My midline equation is y equals -2. So my answer is A. Okay, B, they approached it as if it was +2 instead of -2. All right. So here's your general format. Again, they use H and K where I use C and D. Just understand that those are variables. Okay. So this process is that we're going to go through is we're going to determine the vertical shift and graph the midline. We're going to determine the amplitude if it exists. We're going to determine the period and then take our X scales, and then we're going to determine the phase shift and translate the graph accordingly. That's step 4 is the big one that I have a problem with. If you take care of the phase shift and use your X scales, we don't have to graph one and then shift it. We're just really graphing one. Okay, so the book's method, they want you to graph the original, like A sine of d theta, and then shift that one accordingly. But that's more steps. It's a little bit redundant. So if we just factor in and distribute B, we're going to be okay. Like here. So you can see this is a tough equation. We have y equals 3 sine of 2 theta minus pi halves plus 4. Then we're going to graph this equation. Okay, this is probably the most complex questions that you're going to have. But we're going to talk about phase shifts with tangent as well, because I should have a little bit more. Why am I erasing that? I did not want to do that. Dang. Dang it, doctor, you got me all flustered. Flustered. Okay, so I'm writing up the original equation. Y equals 3 sine of 2 theta minus pi halves plus 4. Okay, and then, like I said, I'm distributing this to inside. Okay, and what I'll be left with is y equals 3 sine of 2 theta minus, that turns out to be pi. No, 2 over 1 times pi over 2 minus pi. Okay, there we go. Perfect. I'm still good. Plus 4. Okay, so this is really the equation I want to use. Okay, because that allows me to set whatever is inside, okay, equal to 0. Here you can see it's going to be a phase shift to the right of pi halves, but it allows you to do it a little bit simpler. And this will be consistent with the tangent function as well. Just makes my life easier. That's why I do it. So amplitude comes from the absolute value of A. A is 3, so the amplitude is 3. Okay, the period. Okay, we're using radians here. So if I take 2 pi divided by the absolute value of 2, I get pi. Okay, my X scales. I find the period that I just found, which is pi. I divide that by 4, and I get pi fourths. Okay, my phase shift. If I set what's equal to bx plus c or bx minus c, if I set what's inside the parentheses equal to 0 and solve for theta, shows me where my phase shift is. So I have 2 theta minus pi is equal to 0. I'd add pi on both sides. Divide by 2 to get that theta is equal to pi divided by 2. And if you look, it matches, right? But this is just an easier way to consider it. The vertical transformation is at plus 4. So my graph is shifted up 4. Okay. So first, drawing my graph. Okay, my midline is here at 4. Okay, I'm shifting right, so that's okay. Draw my x-axis down here at 0. Okay, my amplitude distance from the maximum and the min. So I have a maximum of 7 and a minimum of 1. Okay, now I can start to fill out my x scales. So my phase shift is to the right, so I'm no longer starting on the y-axis. I'm going to start at pi halves. Okay, and then I add pi fourths to it. In order to do that, I have to have a common denominator. So pi halves is really 2 pi over 4 to get my common denominator of 4, so I can add fractions. And if I add pi over 4, because that's what my x scales tell me to do, my next critical point is at 3 pi over 4. Okay, if I add pi fourths to that, 3 pi over 4 plus pi over 4 is just going to be equal to pi. Okay, 4 pi over 4 plus pi over 4 is equal to 5 pi over 4. One more, 5 pi over 4 plus pi over 4 is equal to 6 pi over 4, which could be reduced to 3 halves or 3 pi over 2. Okay, the hardest part about dealing it in radians is that we have to have common denominators when we're taking our phase shift plus our x scales. So my phase shift was pi halves to the right. Okay, in order to add pi fourths to that, I needed to have the common denominator of 4. So I would multiply each of those by 2. Okay, to get the denominator of 4. That's how I got 2 pi over 4. Then I added to get 3 pi over 4. I added again to get pi. And I got 5 pi over 4. Then I added again to get 6 pi over 4. Okay, but that's all just common denominator stuff. Okay, so now I can start to graph my equation. Okay, it's sine function, so I start on the midline right there. Then I go to the maximum value, which is 7. Then I go back to the midline. Then I go to the minimum value. Then I go back to the midline. What are you laughing at over there, giggly butts? You all right? I hear you kind of giggling.
Huh?
You all right? I hear you kind of giggling. So.
I wasn't giggling, I was stretching.
Okay. All right. Say sometimes you got to stretch, man. I get it. Okay. So the function is written in the form a cosine of b theta plus k. Identifies the values of a, b, and k. So k is our vertical shift. A is the amplitude of 3. B is 2. So 2 pi over 2, that's how you get pi. Phase shift is pi halves units to the right. Okay, K is 4, so the vertical shift is 4 units up. Remember that we are moving the midline, not necessarily the whole function. So we graph the midline first. The amplitude is 3, so we go from 7 to 1 from the midline. The period starts so you can see here they haven't considered the phase shift. So they shift it to the right. So we're concerned with this dark blue function. See, I don't like the concept of graphing 1 and then shifting it. I would rather just graph 1 and have it be right. But you can see I start at pi halves. Then at 3 pi over 4 is my maximum. Then pi, I go back to the midline. Then at 5 pi over 4, I hit my minimum. And then at 3 halves pi, I get back to the midline. Then this would be 2 pi for my maximum. Okay, I don't necessarily like the way the book has done this. Okay, for this question, we can just use it in this format. Okay, the phase shift is going to be pi over 4 to the right. Okay, the period is going to be 2 pi over 3. The amplitude is 2, and the vertical shift is a -2. So absolute value of A is the amplitude. Period, take 2 pi divided by 3. Phase shift is just pi force. Vertical shift, so looking at this answer, this question looks like the correct answer is going to be C. Which is really weird because it's the same answer as B. Huh. Interesting. Very, very interesting. Okay. So the height of the water in a wave pool oscillates between, we're not going to do that one. Because I didn't do that. We're going to do a tangent one. I'm going to find it from your homework. Let me get through all this. Go to Seesaw. Thought I had it open. I don't. Okay, so here we're going to do number 18 together. Okay, because tangent, all the slides correspond to cosine and sine, which are the ones that I really beat in the submission the other day. So hopefully those are inserted in your brains, but we're going to be looking at this one. So we have y equals the tangent of 1/2 theta plus 30. Okay, and if you remember from the other day, tangent is really about finding x-intercepts and asymptotes. Okay, so very similar. The first step that I want to do is I want to distribute this 1/2 into the parentheses. Okay, so when I do that, 1/2 times theta is going to give me 1/2 theta. So I'm really graphing tangent of 1/2 theta, and then 1/2 times 30 is 15. So I'm really graphing 1/2 theta plus 15 all on the inside. Okay, tangent, it breaks down by finding x-intercepts and asymptotes. Okay, but first we got to find the period. Okay, so the period for tangent, okay, this one's in degrees, so we take 180 divided by the absolute value of b. My b value is 1/2, so that's tangent, or 180 divided by 1/2, which gives me 360 degrees. Okay, that's how long it takes for me to complete one cycle. Okay, my x-intercepts. Okay, now if I take what's on the inside of my parentheses here, set it equal to 0, because the original function of tangent crosses through the origin, right? That's the first x-intercept. If I take 1/2 theta plus 15, set it equal to 0. Okay, so -15 or -15 on both sides, left with 1/2 theta is equal to a -15. Divide by 1/2 on both sides, gives me theta is equal to a -30. So that's my first x-intercept. Okay, the next one occurs when I add 360 from. Okay, the asymptotes. Okay, on the original one, tangent had on the parent function, tangent has an asymptote at positive 90 degrees and negative 90 degrees. So I'm going to set what's on the inside of those parentheses to those to see where they have moved. So 1/2 theta plus 15, set it equal to a positive 90 and solve. So minus 15 on both
Please
sides.
excuse this interruption. That concludes our lockout drill. Thank you for your cooperation. You all did an excellent job.
So 1/2 theta is equal to 75. If I divide by 1/2 on both sides, I get that my first asymptote's location is at theta equals 150 degrees. Okay, to find my first negative asymptote, I take what is on the inside of the parentheses and I set that equal to a negative 90 degrees. Okay, so I minus 15 on both sides, gives me 1/2 theta is equal to a negative 105. Divide by 1/2 on both sides. That gives me that my first negative asymptote, theta, is equal to a negative 210. Okay, here I can see that it's going to make sense, right? And that's because my period was 360 degrees. That means I should have 360 degrees between both of my asymptotes. Negative 210 or 150 minus negative 210 is 360. Okay, 360 plus a negative 210 is 150. That's all good information for me to use. So I'm going to take this information and I'm going to graph it. Okay. First, this is my first x-intercept, my first positive asymptote, my first negative asymptote. Okay, so I'm going to graph it. Here's my y-axis. Here is my x-axis. Says at negative 210, I have an asymptote. Bang, 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 bang. Okay. My first intercept is at negative 30. My next asymptote is at 150. Okay, and there I can graph and I can handle everything and I answered all the questions. State the amplitude, it's tangent, and there is no amplitude. The period is 360 degrees. The phase shift is a negative 30 degrees. Okay, but if I distribute this in, right, then that allows me to set it equal to 0 to solve for my x-intercept and my asymptotes. Okay, but if I don't distribute that in, then I have to find those asymptotes, which would be 180, and then I'd have to shift it. So it's just kind of redundant work. That makes sense. All right.